Okay, so I did another slapdash review of exam 3, and so now you should have all the exam questions answered for you. Yeah, it's a bit slapdash because babies are waking up earlier than I expected, so I only had a few minutes to throw everything together. So hopefully you find it helpful, and we can go and jump into it. Okay, so let's see if I can get this done in one run. Alright, so this is exam 3, and so this had 10 questions, and these are all about Laplace transform. So if you've been following all the YouTube videos for Laplace transform, this is basically the exam I gave, if not in my class. If you're in my class, well, this should all seem very familiar. Alright, so this first one says that given that y1 of t is equal to 1/4 times sine of 2t is the solution to this particular differential equation, and this other thing is the solution to the other particular differential equation, use the superposition principle to find general solution to this overall thing. Okay, so this one actually is from another section, section 4.5 of Nicholas Affenstein, and this is coming from the superposition principle. This is actually the only question that doesn't have anything to do with Laplace transform, and that's just a holdover from what we did just before the quarantine. Okay, so we can go ahead and do this. So the idea of the superposition principle is that both of these equations have y double prime plus 2y prime plus 4y is equal to something, and we're basically trying to relate it to t plus cosine of 2t. Okay, so the first equation is so this whole sine thing is a solution to this differential equation, except there's a 2 here and not that. So basically the solution that we're going to get from that is going to be twice y1, and then we're going to add, it looks like this guy was a solution to just this, and it's still a t that matches right here. So it's just going to be plus y2, right? So this is a particular solution, and this is going to be, say, 1/2 of sine of 2t plus t over 4 minus 1 over 8. And if you were hasty and didn't read the question correctly, slowly and carefully, then you would say, aha, well, that guy is right here. Unfortunately, I asked for the general solution. So that means we need to find the homogeneous bits so we can add C1 and C2. Alright, so what is the homogeneous solution to this differential equation? Is y double prime plus 2y prime plus 4y is equal to 0. And we're looking for a solution to that, and that's going to come from r squared plus 2r plus 2, or plus 4, rather, which is equal to r plus, nope, we can't actually factor that. So, sorry, this should be equal to 0, and we're looking to solve for r. R is equal to negative b plus or minus the square root of b squared, so 4 minus 4ac, so that is 16 all over 2a, and that's just 1. So it's going to be negative 2 plus or minus the square root of negative 12 over 2, and this is negative 1 plus or minus I, and then it's going to be square root of 12. Square root of 12 is square root of 4 times 3, so it's going to be 2 root 3, and so it's just going to leave us with root 3, right? So that gives me my homogeneous solutions are going to have this inside a cosine and this inside of an exponential, and so we're going to have, say, c1 times e to the minus t times cosine of root 3t plus c2 e to the minus t sine of root 3t plus 1/2 of sine of 2t plus t over 4 minus 1/8. And this is a particular solution, right? And you'll see that right here. Okay, so that's problem 1. Let's go on to problem 2. Use definition of the Laplace transform to find the Laplace transform of f of t is equal to this piecewise defined equation. So if I want to write f of s, that's going to be the integral from 0 to infinity of f of t e to the minus st dt. And now this is going to be the integral from 0 to 1 of e to the t times e to the minus st dt, and the rest is just 0, so it vanishes. Okay, so it's going to be integral from 0 to 1 of e to the 1 minus s t dt, and this is equal to e to the 1 minus s t divided by 1 minus s, value at 0 and 1, so that's going to be e to the 1 minus s divided by 1 minus s minus what we get when we put in 0, so it's going to be 1 over 1 minus s. Right? And this is e to the 1 minus s minus 1 over 1 minus s. And that looks like it's this. All right, there we go. Okay, number 3. If I use the Laplace transform table and linearity to determine the Laplace transform of this thing. So basically we need to figure out the Laplace transform of 2. We need to figure out the Laplace transform of e to the 3t. And we need to figure out the Laplace transform of e to the t sine of 2t. Right? Laplace transform of 2 is 2 times the Laplace transform of 1, and that is 2 over s. Laplace transform of e to the 3t is 1 over s minus a, or 1 over s minus 3. Laplace transform of this guy is going to be Laplace transform of sine, which would give me 2 over s squared plus 4, and then we're shifting it by 1, so it's s minus 1. All right, so the answer that we get is all these three guys added together, so 2 over s plus 1 over s minus 3 plus 2 over s minus 1 squared plus 4. All right, and so, oh, not plus on that last one, that should be a minus. Like that. All right, so 2 over s, the first three have those, s minus 3, that's on the first 3, good. And on the last one, we have this guy, yep, okay, so looks like it was this first term here. Okay, cool, let's go on to the next one. Use properties of the Laplace transform to find the Laplace transform of t cosine of 3t. All right, so we know the Laplace transform of t times f is equal to minus d by ds of f of s, right? So this should be equal to minus d by ds of the Laplace transform of cosine, which is, let's see, it's going to be s over s squared plus 9, I think, right? And so taking the derivative there, we use quotient rule, so derivative top is just s times the bottom, s squared plus 9, minus the bottom, s squared, minus the derivative of the bottom, which is going to be 2s times the top times s, all over s squared plus 9. Okay, and putting it together, see we get s squared minus 2s squared, that is going to be a minus s squared, and so it's 9 minus s squared on top over s squared plus 9. Then we have minus sign, we integrate that in, that's s squared minus 9 over s squared plus 9. And there we go. And, oh, sorry, quotient rule, you should square the bottom. That was a mistake. There we go. And so that gives me this guy. Okay, cool. Question number 5. If f has a Laplace transform, and so we're saying f of s is equal to 5s squared plus 2s minus 1 over s to 5. They want to know what function has a Laplace transform. I'll call this g of s for now. 10s plus 2 plus 5 over s to 6. Okay, well, we could go ahead and work through each and every single one of these and see what Laplace transform it gives me, and that would just be using the properties of the Laplace transform. For instance, this one we don't actually have anything good on, but this one gives us a shift. This one multiplied by s and then take a derivative, and this one is about taking a derivative of Laplace transforms. Okay, so what we notice is that actually this guy is actually just equal to the derivative of our Laplace transform. And remember, I just said that we have d by ds of f, right? But we have minus sign here, and that's not appearing up top, so it's minus tf is equal to d by ds f, and that's the answer. And so that would be this guy. Okay, next one. Which is the correct form of the partial fraction decomposition for the rational function 1 over s cubed minus 1? Right, well, this factors as s minus 1 times s squared plus s plus 1. And this guy happens to be irreducible. So that's going to give me a over s minus 1 plus bs plus c over s squared plus s plus 1. Okay, so now we need to figure out a, b, and c are. If I multiply both sides, I get 1 is equal to a times s squared plus s plus 1 plus bs plus c times s minus 1. Choose s equals 1, and what does that give us? That gives us 1 is equal to a times 3, which tells me 1/3 is equal to a. And then if I now want to figure out something else, maybe let's choose s equals 0, and that's going to give me 1 is equal to a plus c times negative 1. And then what is that going to give me? Well, a is equal to 1/3, so it's going to give me 2/3 here on the left. It's equal to negative c, so that tells me that c should be equal to minus 2/3. Right. And so looking at this is the only thing that has negative 2/3 on there. So if I want to bother finding a b, then that's it. I'm done. If you want to find b, then you can just pick another value, say s equals negative 1, and then we can just go ahead and plug in what we know for a and c. So for instance, we're going to get a1 is equal to, say, 1/3 times, it's going to be 1 minus 1 plus 1, so it's going to be 1 plus negative b minus 2/3 times negative 2, and then go ahead and solve for b. Okay. Question number 7. Change the following differential equation to another differential equation using properties of the Laplace transform. Okay, so the differential equation we're given is y double prime plus ty is equal to 1, and they tell us that y of 0 is equal to 0 and y prime of 0 is equal to 1. Y double prime becomes s squared times y of s minus y of 0 times s, and that's just 0, minus y prime of 0, which is 1. Then we get plus the Laplace transform of of ty. Well, we know the Laplace transform of ty is actually equal to negative d by ds of big Y. So I'm going to put, instead of plus, I'm going to put minus y prime of s is equal to, now we had a 1 on the other side, so it's 1 over s. Okay, so altogether we have an s squared times y of s minus y prime of s is equal to 1 over s minus 1, so we get 1 minus s over s. Okay, and then we add in this extra constraint of y of s goes to 0 as s goes to infinity, because we want to make the assumption, so the assumption is that y of t is of exponential type. All right, just an assumption we make on top of this, and so this all together gives us our new differential equation. And that shouldn't have been, that should be a plus there, sorry. We're moving a minus 1 over as a plus 1. And so ultimately, that gives us this guy. Okay, so now we're going to use the definition of Laplace transform again to find the Laplace transform of little f of t. So f of s is equal to the integral from 0 to infinity of f of t dt, and this is going to be the integral from 0 to 1 of 1 minus t. Oh my goodness, what am I doing? So taking all of this, shifting it over, and I need to add in e to the minus st. Okay, once that's done, we have 1 minus t times e to the minus st, and then we have plus the integral from 1 to infinity of e to the minus st dt, right? Okay, so first bit is integration by parts, if you like. And in fact, let's do integration by parts. Okay, so we're going to have u is equal to 1 minus t, and that gives me a du is equal to minus dt. And that's going to leave me with dv is equal to e to the minus st, and that leaves me with v is equal to 1 over minus s e to the minus st, right? And so when I do that, I'm going to have u times v, which is 1 minus t, times e to the minus st, divided by minus s, evaluate at 0 and 1. And this guy I'm going to write as limit as n goes to infinity of integral from 1 to n of e to the minus st dt, right? Okay, now let's see. I'm going to have, oh jeez, this is what happens when you're trying to rush. I forgot that whole chunk of the integral. And so here again it was the integral of v du, right? So 0 to 1 of v, which is 1 over minus s times e to the minus st. Then we have a minus dt coming out of our du, so that kills the minus sign on the minus s. Okay, so evaluating this first term at 1 is going to give us just 0. And evaluating it at 0, so we're going to have minus of e to the minus, or say just minus 1 over minus s. That's that first term. Minus 1 over s times the integral that we get out of this, which is e to the minus st divided by negative s. And this is valued at 0 and 1, plus the limit as n goes to infinity of, let's see, evaluate at 0 and n, e to the minus st over minus s. Okay, so we get 1 over s out of this guy, minus 1 over s times, when I put in 1, I get e to the minus s divided by minus s. When I put in 0, I get 1 over minus s, plus the limit as n goes to infinity of this guy, when I put in e to the minus sn over minus s minus 1. That should have been 1 here, not 0. Over e to the minus s over minus s. Okay, this term goes to 0. This term sticks around. So we get 1 over s minus, let's see, we get 1 over s squared minus e to the minus s over s squared, and so we have minus on that. It should be a plus on this, and should be a minus on the other one. Yeah, okay. Minus e to the minus s over minus s. Okay, now if we combine everything together, we get s minus 1 plus e to the minus s e to the minus s divided by s squared. All right, that's question 8. Okay, let's see. Next one, solve the initial value problem using a Laplace transform. So, we have y double prime minus y prime minus 2y is equal to 0. Taking Laplace transform on both sides is going to give me s squared Laplace transform of y minus s times y0, and then minus y prime 0, but that's 0, so that goes away. Now we're subtracting y of s times s minus y of 0, so minus 1, then minus 2 big Y of s is equal to 0. Okay, so we're going to have s squared minus s minus 2. All right, yep. And this times y of s is equal to s plus 1. All right, so we have y of s is equal to s plus 1 divided by s squared minus s minus 2. And does that factor? Yes, indeed it does. It factors as s plus 1, s minus 2. Okay, so now we use partial fraction decomposition. So a over s plus 1 plus b over s minus 2. Multiply both sides, so we get s plus 1 is equal to a over s minus 2 plus b over s plus 1. And now I get setting s is equal to 2. What does that give me? It gives me 3 is equal to b times 3, so that tells me that b is equal to 1. S is equal to negative 1, gives me 0 is equal to oh my god. Yeah, I'm an idiot. Okay. Well, let's keep going. Alright. A times negative 3, or whatever the heck, because that tells me that a is equal to 0, which tells me it should have canceled in the very beginning, because we could have canceled it here, which would have left me with just s minus 2. Alright, well, at least I'm validated, I guess. Alright, so that tells me then that this is just 1 over s minus 2, and so then it tells me that y of t is equal to e to the 2t. Right, there we go. Okay, so you didn't have to do partial fraction decomposition here at all. That was just me screwing up. Alright, so next one. What do we get? Determine the inverse Laplace transform of this guy. So we're given 1 over s squared times s minus 1. Alright, if we want to determine the inverse Laplace transform, we need to use partial fraction decomposition and then apply our table. So it's going to give me a over s plus b over s squared. That's what you do for repeated roots. Plus c over s minus 1. Multiply both sides. So we get a is 1 is equal to s times s minus 1 plus b times s minus 1 plus c times s squared. I choose s is a equal to 0. And what does that give me? It gives me 1 is equal to negative b. So that means that b is equal to minus 1. S is equal to, say, 1. Alright, what is that going to give me? This gives me 1 is equal to c. Alright, so we have that. Now let's figure out something else. I'm just going to choose s equals minus 1. If I choose s equals minus 1 on the left-hand side, I get 1. On the right-hand side, I get a times negative 1 times negative 1 minus 1. So that is times negative 2. So it gives me 2 plus, well, we now know b is negative 1. And I plug that in, and that gives me negative 2 here. And then I get plus c, which I know is 1, times negative 1 squared, and it's just 1. All right, so what is that going to give me? It gives me, this is 2, and 1 cancel, and so it gives me that a is equal to negative 1. All right, so let's invert Laplace transform it. So Laplace transform inverse of s squared times s minus 1 is equal to, it's going to be a, which is negative 1, right? 1 over s, the inverse Laplace transform that just gives us 1, so that's it. And now we have minus, let's say plus negative 1 out of the b, and 1 over s squared, that's going to give me t. And then I get plus c, whatever c was, which was 1, and that's going to pop out in e to the t, because e to the t's Laplace transform is 1 over s minus 1. Alright, so altogether we get minus 1 minus t plus e to the t, boom, and that is the exam. Sorry if that seemed a little bit rushed. My children are getting more and more active in the background. The television is likely to go on in a second, And yeah, so this was my only 10 minutes of quiet time. Okay. In any case, I hope this helps, and now you have an idea of how to do everything, even if you have to play in slow-mo. Okay, so that was exam 3, and hopefully that helps. The only thing that doesn't cover is a little bit of stuff on the convolution theorem. Just try a couple problems out of section. I don't have anything particular to tell you what to do. The exam question is just going to be really a bare application of it, so it shouldn't be too hard. Yeah. In any case, this has been a lot of fun, and it's likely going to be the last official video I have for the class. I'll post some extra stuff. I have a fractional order calculus video I'm putting together, and I'll keep this channel going for a while. But yeah, thanks for being in my class. I am really sorry that this quarantine just threw a wrench in everything. Nothing we could really do about that. You remember that joke I made about how with the coronavirus we really shouldn't be gathering in groups of like 50 in a classroom? Not really a joke, but more of an ironic observation. And well, yeah, that was just hilarious, wasn't it? Anyway, yeah. So this has been a roller coaster of a semester for everybody, and I hope everybody's staying happy and healthy. And good luck on the final.